Yes, Chris here. I wanted to make another video showing some of the improvements to the project I've been working on for quite some time now. This is Pisces. It's a Raspberry Pi based GPS navigation topographic viewer computer for my John boat. Now, I fish lakes that don't have topo maps available in some of the major sounder units, like I don't know what's called, lake view maps and such. But anyway, this is a project that I've built that's based on a Raspberry Pi. I import maps into it. Right now I'm not on a lake, okay, so I'm just importing the my neighborhood here, and as you can see, I have a few waypoints there. You can see there's a few. It's hard to tell. One of the new things I've got integrated into it is a digital compass. This is an Adafruit LSM303 tilt compensated compass module, magnetometer and accelerometer. And if you notice there, I've got pitch and roll values. So now if I tilt this way, this way, this way, I can measure the tilt of the boat, but I don't really care so much about that. I'm using the accelerometer to calculate tilt to compensate the compass. Now right here is my heading based on this compass. Okay, so if you watch here, I got a little icon on there. It only shows like north, south, east, west, southeast, northeast, those cardinal points of the compass. It doesn't show all of them. Okay. Now, one of the other unique features that I've added here is to track a waypoint. Now, when I add a waypoint onto, if I'm on a lake here, and I hit the waypoint button, it puts a waypoint on there. Okay, so now on the graph you see on the right, it's a polar graph that shows the dots that's moving is my current compass heading. Now the other dot is the heading to waypoint number 7, which is 52 degrees and it's 289 feet away. So if we zoom in here a little bit, I don't know if you can see waypoint 7, but if I want to get to waypoint 7, I have to go to when the two dots are on each other, I'm on course to reach that waypoint at 290 feet. Okay, so then as I get closer to that waypoint, this dot will slowly come into the center, and if I'm within 10 feet of that point, which is this coordinates, these GPS pair here, this is my current GPS, this is the current GPS coordinates of the waypoint. So this dot will move in, and when I'm within 10 feet of that point, the beeper will chirp inside the unit. Okay, so around the one that's moving is my current heading from the compass, from the magnetometer. Okay, so now as we go around here, so now if we're moving, let's say we're moving now. The boat's moving. When the dots are on top of one another, I'm on course to hit the waypoint. Now I also have, you can set different waypoints. It only shows the waypoints that are currently saved. So now here I've selected waypoint 4, and it says my current position. It's 239 feet away from my current position, and I need to move the boat on a heading of 112 degrees to reach waypoint 4. Here's waypoint 4 down here. It's waypoint 4 down here. So, and the little red square with the arrow on it, that's basically the "you are here" mark, and it shows only the north, south, east, west, northeast, northwest, those cardinal points. So you'll see the heading change appropriately. So here we're heading north 360 degrees or 0 degrees. Okay. Down here in the bottom is my current position. Now granted, this is just showing where I live because I'm not on a lake right now. So I also have the ability to integrate into maps that since I'm not on that lake, you know, I can't really show active here. Okay, so here's Salamone Lake, the beach cove, one of the best places to fish out there. I can't really show waypoints here because I'm not on that lake, so but it still shows my current position and my heading and the time, the pitch and roll. Oh, and also too that I have this control my live well. I have 2 pumps in my live well where I control the duty cycle of the pumps. One pump is mounted on the transom of the boat under the water, and the other one pumps that pump on the transom pumps fresh water in through a spray bar and oxygenates the water, and then another pump pumps water out over the side back into the lake. And so I control these pumps. I control their duty cycle and how often they turn it on and off to save the battery power. And I also have a float switch in there to prevent the live well, which is essentially an igloo cooler, from overflowing. Okay. Now I have up here at the top on the tidal bar, I actually show the CPU temperature of the Raspberry Pi. I show the current map selected, and I show the GPS status. This project is using a feather light. I forgot what Adafruit called it. GPS board, and it's also this compass chip. This also came from Adafruit, and I have a calibration routine in there where you rotate it through all the axes, and it saves a calibration value, and it's tilt compensated too from the accelerometer. So let me go back to here. This form here shows I can select what lake. I have a bunch of lake maps integrated into it, and here's where I control the live well control. You know, it's interval and duration, so it'll run for 1 minute every 1 minute, and then as it's pumping in, it's pumping out to turn the water over. Okay, here's the manage marker screen if I want to delete certain points or show the waypoints and hazard points. Like hazard points are like logs in the water. Like if I want to mark a underwater stump that I keep getting hung up on. I have a virtual keyboard here in case I need to change the map geometry, etc. I have a little about box. Let's change back to a real-time my hometown here and save it. The only thing I haven't done yet is when you have to restart the program whenever you change a map. I have not changed or fixed that yet. Okay, so here's the waypoint navigation screen. We want to navigate to Seis function, or to waypoint 6. That's the sound it would make when we're within 10 feet of the waypoint. It does that because it hasn't been initialized when it starts, which is something I gotta fix. But as you can see here now if we're navigating to waypoint 6, you can see it says I'm going to go to waypoint 6, and the heading to waypoint 6 is 305 degrees, and it's 107 feet away. And if you look over here on the map, if it'll focus, where's waypoint 6? Waypoint 6 is up there. And obviously, if you watch, we want to see how the two dots are joined together. So we want to hit the waypoint at 306 degrees on the heading. And if we maintain that course, we'll reach the waypoint that's 111 feet away. I haven't calculated the time yet, because obviously we're not moving. I haven't added that feature yet. So basically, this is Pisces, which is my John Boat navigation waypoint computer, and all around being a computer programmer, software engineer, I wanted to find a reason to have a Raspberry Pi in my boat. This whole project was born about the fact that I wanted speed